All right, we're recording. Welcome to College Algebra.
Welcome to College Algebra.
You're already embarrassing me. I'm Corey Bobby.
I'm Jana Young.
Good, I'm glad you were going to say that because I was afraid you were going to leave me hanging. We're a couple math geeks. I work at a place called Dawson Cooperative in Arkadelphia.
I forgot the name of the place he works.
Yeah, whatever. And Jana, you want to tell them where you actually work?
Yeah, I work at Eastham High School in Little Rock.
And we were teachers at Lakeside for a long time together years ago, but then we both moved on to other opportunities. But they brought us back to try to do this virtual class, so hopefully we don't mess it up too much. I am officially your teacher of record for this class. I will be the one officially signing the grades, but
I'm a bonus teacher.
Bonus teacher, but we both. And Miss Young will be the official teacher of AP Statistics. But I will be helping in that class, and she'll be helping this class. So basically, you're going to hear from both of us a lot. So, and that's okay. It makes the class a little more fun.
Yeah.
So I'll make it fun. Miss Young will just be here. So, and there's me doing that stupid hitting the wrong button again. Okay, so let's tell a little bit more about ourselves because I almost called you Jana. Can I call you Jana? I don't think.
Sure, call me Jana.
You know what? We're Jana and Corey, unless
our bosses are near, and then we're Miss Young and Mr. Body.
Yeah, that's fine. We're cool with whatever. We probably should have decided that before. Oh well, too late now. Anyway, this picture pretty much perfectly encapsulates us, don't you think?
I think yeah.
We were in some Chinese restaurant eating noodles or something.
We were in Threefold eating lunch. Yeah.
Oops, and I went the wrong way. So I'm what's called a curriculum facilitator. Basically, I wasn't a bad teacher, so they told, but I wasn't a great teacher, so they said, why don't you go teach other teachers instead of teaching students? My biggest obsession is, one of my biggest obsession is shoes. I have over 120 pairs of shoes, so every video will include, and because y'all are Lakeside, I decided to break out the Lakeside blue snakeskin. And at some point or another, I think you'll learn about my motorcycle habit, and I have a very annoying corgi that probably will break into some video at one point.
And I was a teacher, am a teacher, and I'm also now a curriculum facilitator, which really just means we help teachers. And I have a daughter who is going to be a second-year college student at UCA, and a husband, because, why not? And sometimes I run a little bit, and then also I have some dogs too, and they're quite lovely, and we both are big dog people, so you're going to probably see our dogs more often than you'd like. Mm-hmm. All right, let's teach some math.
She's not a little bit of a runner. She runs like marathons and stuff. The other stuff that's on here, you keep moving us around. This class, just quickly, we're going to have, you have the syllabus. We're going to have 5 modules in this class in College Algebra. I think you're going to be with us for both College Algebra and Trig. We'll deal with Trig second semester. But there will be 5 modules, and each module will conclude with a test. We are going to do something a little different with this class. We are going to make you come in one evening, in an evening periodically, probably like every 3 or 4 weeks or so, to take a test or to do something. So we'll send you that. All those dates will be in the calendar and the syllabus. We'll be using an online management system. I think it's Google Classroom. We're still making this video before we actually are getting started. So all of that will come there. You'll have your friendly neighborhood college algebra textbook where you can get your assignments, but there'll be quizzes and such. And we will be available for office hours. We'll also make that available to you. We'll be available via Zoom for you to jump online, ask us some questions, and do whatever you need to do. Okay? So, all right. So we're going to start talking about some math now because Miss Young can't keep her mouth shut. She wanted to tell. She's going to show you how smart she is. So you have your.
A function is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to exactly one member of the range.
That wasn't acting. She's actually that flamboyant. So there's what she just read. And that doesn't make a whole lot of lick of sense to me. And I have a master's degree in mathematics. Like, I like to do this for a living, and I like this stuff. I know some of you maybe don't, but I actually do. And why do mathematicians write like this, Miss Young or Jana or whatever I'm supposed to call you?
I'm glad you were only picking those two names.
Yeah.
Mathematicians write like this because they have to cover so much information that they need really specific words to make sure that what they say is true for a lot of information.
You're right. And I'm making fun. We will make fun of ourselves and we'll make fun of mathematicians, but we both really love, in addition to loving dogs, we love math. And this is an airtight, gonna hold up no matter what kind of definition, but it does make it a little hard to understand when you're learning. So I want to just step back and say, what does the word function mean, like, as a word in the real world? So, like, how would you use it in a sentence? How could
and in case you're wondering, we discussed this lesson before we started teaching you this lesson, and Mr. Bobby said they're all going to think bodily function. He thinks you're going to think about poop.
I didn't say that word, but I said bodily function. And in that example, what's the purpose of a function? It's some kind of process or procedure that has to be done. Oh gosh, now this conversation is anyway. It's some procedure that has to be done and has a predictable outcome. Is that fair?
Yeah.
Okay, that makes sense. So, like, what's the function of a can opener? The function of a can opener is some kind of contraption that allows me to do its thing, and boom, I can get into the soup or whatever is inside the can. Okay? So there's some kind of predictable outcome that comes from the process of doing this function, and that's what it means. So, gosh, I gotta keep hitting the left arrow. Just hit the mouse. Oh, I put you away. So what it really means is there's something I can do, something I can measure, but there's really something I want to know. There's something that I really care about that's controlled by something else, okay? So there's something I care about that I can't control. All right, that's a great word, but there's something that controls it. Oh, look at me, right. And that arrow goes over there. I was actually doing better with the writing earlier before this video. So anyway. And my prime example is something about, and if I want to care about my weight, I would maybe exercise more, and maybe, or my blood pressure. If I care about my blood pressure, because I'm getting old, yes, I'm an old fart. How can I control my blood pressure? I could eat better, or I could exercise. So the thing that I care about is actually the range, okay? And the thing that I can control is the domain.
In previous classes, you might have heard this, like independent versus dependent or something like that. Or even maybe in your science classes, you might have heard independent and dependent. Same thing. What's dependent on, what's my weight dependent on? Diet and exercise. What's my cholesterol dependent on? That kind of thing.
There's some kind of relationship, some kind of dependence. Now, for me, my relationship with my blood pressure and my level of exercise will be different than for Miss Young. Every human being has a different relationship, and that's why it's so difficult to come up with these kinds of equations. Okay?
Yep.
So, all right, let's look at I got to clear my annotations before I advance the slides. You're going to have to adjust, at least for the first few lessons, to us getting comfortable with a lot of different things.
Yeah.
So here's a few other examples. The domain might be the year of a presidential election. So if I were to say 2016, oops, no, not that. Got to grab my pen back. So if I had the year 2016, that's in my domain, and then the output would be Trump. And the relationship is the person who was the person who was elected. And that's not a mathematical function, but there's a one-to-one correspondence. There's not two winners. I don't care what Hillary says or what anybody else says. There's one recognized winner for 2016. If I were to do the same thing for 2008, who is the winner in 2008? Obama.
And this is interesting because he could actually go back to 2004 and guess what would happen? So go ahead, Mr. Bobby. 2004, previously before 2008, who won?
That was Bush, wasn't it?
It was Obama again. So you can see here that Obama ran, yeah. So my point here being that you can have the domain mapping, and we're going to talk about that word later, to the same thing over there in the range. But he's right. You wouldn't see, say, two winners from 2016. 2016 is only going to map to one place. But you could, in this instance, and in many instances of functionality, map two domains to one range.
Right. Okay. So we can do this with other relationships. And she was making fun of me for doing political examples, but I really, now I kind of like politics, and I can't believe I'm embarrassed. I didn't you got history there. But if I were doing this in the states in the United States, and that's about to change when the 2020 census, or it may change. The state of Arkansas has, we have, how many representatives do we have? We have 4, okay? And so the state of Arkansas is connected to 4. Now that actually is determined by our population. So when the census comes out, it potentially could change. I don't think it's going to change for us, but there are states who may lose representatives, okay? So there's some kind of correspondence, and we would care about that because the more representatives we have in Congress, the more influence we have as a country, okay? So there's something I care about. I know many of you, maybe you don't care about the president, but a lot of people do care about the president. And I should have known in 2004 that Obama was president, okay, or was elected president. Okay, the other one that I think is...
You know what? I was wrong. Now that I'm looking at this, what, a 2000...
Yeah, that would have been...
12, you jumped one and I didn't notice. So actually, you're right, I'm wrong. You're right, I'm wrong.
Yeah, I was like, got this is... This should have been 20.
So 2012, you skipped the 2012 election, and that can, like, I just didn't even notice.
No, yeah, you're right. So, yeah, this should have been, that would have been 12 and 18. Folks, this is my first
screen over.
Yeah. Okay. That was my first mistake ever. Oh, when I skipped the slide, that was my first mistake ever. Oh, I gotta get back to my mouse.
Tell me about your first mistake ever.
Last year, was it last year? I guess it was last year when I was teaching calculus. That's my thing. Whenever I make a mistake, I just forget it and roll on. So I always just say that was my first mistake ever. Last year, my calculus class would keep track, and on average, I would make between 8 and 10 first mistakes ever in a 90-minute class period. So, but there's a moral to that story, because when you make a mistake, shake it off and keep going. That's not going to stop me from doing what I need to be doing. The last example is, to me, is kind of my personal favorite. I have a 2018 Indian Roadmaster that's gorgeous. You may accidentally see it in one of the presentations. It is, when I crank the gas, I have an instantaneous fuel economy. Do y'all have that maybe on your car? I don't think Miss Young does, because she drives a jalopy. But when I crank the gas on my motorcycle, what happens to the instantaneous fuel economy? You may have that gauge on your car, but when I'm using more gas, my miles per gallon goes immediately down, because I'm driving faster and using more gas. And when I let up and go slower, the fuel economy goes back up and down. It constantly changes based on the speed with which I drive. So if you're trying to save money, drive like grandma, okay? So
I do.
Yeah, you do. So why is, oh, okay. So let me clear my writings again. Okay, so let's look at, in the math sense, it's usually the domain is the x values and the range are the y's, and they are paired together. There's some kind of connection. So if I were to exercise for 11 minutes, my blood pressure would go down by 2 points. That is what this would mean. So if I were to do this problem, I would take these two that are connected, and that would make what's an ordered pair that I could graph. And if I get enough of these ordered pairs and graph, I can maybe begin to see a relationship in an equation. So those 2 points would correspond to a coordinate pair of 11, comma 2.
How about -2?
Yeah, that's what I said. Guess what that was? Yes.
First mistake ever?
And so those two pairs would make 11, -2. So if I were to make the next relationship here, let me do it in green-ish. I'm going to take 12, and it's connected to -1. And see if I can do this without making my first mistake ever. It would be 12, comma, -1. And I could plot those points, and we're going to do that in a little bit, on a grid. And if I got enough of these, a pattern may emerge. Math is all about patterns.
We hope there's a pattern that emerges. Or we might not, depending on what we're trying to do with it.
Okay. But this gets back to the definition. If you look at all of these x values that I have in this table, they only have one correspondence. There's a problem with the figure on the right, though. And that problem with the figure on the right is right here.
Yeah. So what he's saying here is the phrasing exactly 1 is an incredibly important part of this definition. Notice how -2 maps to exactly 2. And so it kind of, the rule of thumb for the definition of function is now broken. And so what your Algebra 1 teacher probably told you was, careful of those repeating x values.
And what that does for us in the function sense is I've lost predictability.
Yeah.
That's what we're looking for, is we want the predictability so that I can maybe make that generality. Okay, so hopefully that helps you understand. And I realize that a lot of this stuff we're going to do in this first chapter is things you may have seen before, but we're hoping to make it a little deeper. Plus, you know, maybe make you laugh once or twice.
Laugh at him.
You can laugh at me all you want. I'm just okay. I have a corgi. Corgis are the most judgmental of all dogs. Okay, so again, the definitions, a little more definitions. We talked about the x values and the y values, and she used all that language. The x values are something that you can measure, something that you can change, something that you can control. It's not the thing I really want to do. I don't want to exercise, okay? But
I do.
You do, but I don't. I mean, I do, but I don't really want to. But I do want to lower my blood pressure, okay? Or I do want to be able to walk up more than one flight of stairs, okay? I was able to do 3 yesterday without huffing and puffing.
Yes.
I was at her house yesterday and went up 3 flights of stairs. She was making fun. So
I was always.
Always making fun of me. So the way that I think about it is that it has, and I think about the thing that I can measure, or I can change. I like the word change.
Change is better because, like, you can't measure Donald Trump or President Obama or any of those.
Well, the thing that I can decide a year or whatever. And
Yeah.
the thing I want, and that's the domain. Okay. That's why they use the word independent. It's the thing that I can control, right? And then there's the function, and then the range is the thing I want to find out, okay?
Kind of the to be determined.
What are I like that too, or what I need. I need to lower my blood pressure if I'm in health issues or whatever, okay? I need to know who the president is because that may determine my future as an American, okay? So, hopefully that helps you make, and then domains are all the x values. And basically in math, we just list the x values, all the possible x values and all the possible y values. But when it's in a context, it's what thing changes the other thing. And it's often, the range is often the thing we truly care about and we're trying to predict, because we can't predict, like I can't predict my GPA, but I can't control my test score, but I can control how much I study. Yeah. Okay.
Kind of like, and I said I wasn't gonna do this, I'm gonna do it anyways. I kind of like the way that statistics uses explanatory and response variables. You know, the response is your range, your dependent variable, you know, it's what's happening because of.
Mm-hmm. We probably will talk stats. And I may throw calculus at you, but don't worry, we're not going to do class. So, okay, couple ways. So basically, a couple ways the problems are going to look in your homework or in a quiz is find the domain and find the range. So this, we can do this by looking for, I'm going to do pink because as you'll find out, I have, I like pink. So what is the domain is simply, can you draw a brace, a square brace, squiggly brace, this like little thing here in the end? I can't draw those. That's supposed to be.
So that brace, by the way, that he's talking about, that's notation to tell you that he's about to write a set of something. So after the number 1, you see that curly bracket, and everything following it is the set of ordered pairs that we're looking at. And so why he draws it is because he's about to tell you the set of numbers that is the domain of that particular set of points.
Okay. Now, does that bother you, Miss Young, that I didn't put them in order?
Yes, but it's okay.
You have your OCD rocking. Anybody in the audience got OCD or like their things in order? Yeah, you. I used to have a boss who everything on his desk had to be perpendicular. I worked. My boss worked in Dallas, and I worked here in Arkansas. And every time I went to the office, I would go to his office the last day before I leave and turn one thing a little bit askew. So
yeah, you're the devil.
I'm that person, yeah. So if you have OCD, you could have put them in order. It would have been 14, 17, 18, 20, 21.
Yeah.
And you
also, if there were any numbers that were repeating, you wouldn't have to write them twice.
You don't have to write them again. But I'm not going to mark you wrong. Now, just be aware, Miss Young and I are kind of fun and kind of cool, but you probably may not get a math teacher who will let you do that, okay? So if I were going to deal with somebody who wanted this particular, I would then look at all the y values and put them in order. So the lowest, smallest y value is 4.2. What's the next smallest one?
4.5.
Okay.
4.9.
Oh my goodness.
Whoa.
Yeah, we love the Zoom annotation tool. Okay. 4.5.
4.9.
4.9. We're getting
5.0. Ooh, that looks good.
That one was better.
5.3. And you're done.
And I'm done. Okay. All right. And then moving down here, that's actually easier on the table. The numbers here, really these guys right here. Oh, I can't even draw a circle. These numbers right there are the domain, right?
He means all those numbers. He's circling the first 3, yeah. But 4, -2, I think that's a -1, 4, -1. Although he really can circle just the top 3 because the 4 and the -1 are repeating numbers.
Exactly. That, in the interest of time, I'll just do it. You know, I was going to say save time, but you know, we can.
You don't have to write them. I was just following up.
Okay. And so I don't have to list them again. All right. And then the range, we would need this number. This number, I don't need to repeat the 3, do I? Because that's there.
Nope.
And this side. So I'd have 3, 1, and -2. Okay. Moving on. So the next, well, and you may have seen this before. You've probably done f of x in your in your dreams and stuff, but the function notation, if I'm going to use this equation, if this means something to me and is important, and I'm going to use it over and over and over and over and over again, which is what a real mathematician or a computer scientist or a scientist would do, you don't need to write it all out its whole time. You don't have to call me Corey the total package Bobby every time you address me. Okay.
Excuse me.
That's on my birth certificate or something. Okay. That's my that's my name and title. But you don't go around calling everybody by all three of their names. You find a name, and I called her, I could call her Miss Young, or I could call her Jana, but I don't call her, I don't even know your middle name.
Kedron.
Kedron?
Yeah.
I didn't know that. Okay. I don't call her Jana Kedron Young or Mrs. Jana Kedron Young every single time.
Yeah.
I talk to her. I just.
You could use my maiden name too.
Yeah. So instead of calling this by its thing, they use F because mathematicians aren't very great or aren't very interesting. F stands for function. This is they're pretty boring. But if I was like creative, I could call it Bob. Okay, and have Bob of X. And what the X does is it's a way for me to compactly put that number in there. So when I see this.
Yeah. Remember when you're looking at a function that an X in the function serves like a blank when you were in elementary school, where your teacher might have said like blank plus 2 equals 5, fill in the blank. Well, now we say X plus 2. So an X serves the same way as like the blank does.
So everywhere there's an X, in the blank with a 2. And then what is it, minus 11?
Minus 11.
And then I get to like do math and stuff, okay? I would plug that in the calculator, or I would do the arithmetic. What is that?
4 plus 8 is 12, and 12 minus 11 is 1.
Oh, thank you for doing it. And
you're welcome.
So the only thing that I really want to caution you about is when you get negative numbers. Notice how I put the 2 in parentheses. It's probably not the worst thing in the world to do that all the time with these. So if I do negative 4 squared, that's a big problem, especially on the ACT. Maybe many of you are seniors, but you might still be taking the ACT the first semester. Squaring a negative, that means negative 4 times negative 4, okay? And if you put it in the calculator without the parentheses, you're going to pay dearly. But I'm sure other teachers have probably talked to you about that.
Also important to note here while he's writing this out, the number that follows the F, like F of negative 4, is the number that he's putting in the blanks. That number is your input, also known as the domain of the function. So he's plugging in a domain value, and its answer that he's getting, his response to that number he's plugging in, is, in this case, negative 11, which is a range value.
Right. And then this one will just be negative 11 because I'm super smart.
Because all the blanks are going to 0.
All the blanks. Oh, shut up. Give away my secrets.
Notice here again, here's another instance where the inputs negative 4 and 0 are both mapping to a negative 11, which is perfectly fine.
Yep, that's cool. I just I can't put negative 4 in there and get negative 7 and negative 11 out at the same time. I have to have one unique output. Okay.
Right.
Okay, so we'll clear all that and move on. One day I'll get good at this. All right.
You're getting better already.
Well, not really, but thank you for affirming me. You're the nice one.
You just skip the slide.
Because I didn't click my tool first. X and then F of X. And we're going to make a old school T-chart here. And basically when we make a graph, the reason we need the function is because we have to plug in a bunch of numbers to make this graph. And I'm willing to bet at one point or another you made a graph on a calculator. So we're not going to do this a lot. I promise you, we're not going to do this a lot. But we pick a bunch of X values. So the easiest, and my favorite number to do math with is the 0. And that would be 0 squared minus 2, which would equal negative 2. And now,
sorry, go ahead.
I was going to say that, I think you were going to say the same thing I said. That corresponds to the ordered pair, 0, comma, negative 2. Was that what you were going to say?
I wasn't. And I was also going to say now's a good time for us to remember that f of x is really the same thing as y. Y represents the domain or the output. F of x is also going to represent the output, which is weird because it's not what we just told you.
Why?
Because we said f is the name of the function, and it is.
But why?
But,
F
but,
of, why?
but,
That's why.
but, what?
You fell for it. Okay. Sorry. That was
I can't.
a bad joke, wasn't it? So
Yes.
one in there, I would get 1 squared minus 2. What is 1 squared minus 2?
Well, 1 times 1 is 1, and 1 minus 2 is negative 1.
And that would be the point 1 comma negative 1. So I'm going to do this a couple times, and I'm going to get real tired of it. And you're probably already tired of it. I mean, I'm already tired of Miss Young yelling at me, but that's okay. If I do negative 1, I definitely want to put my parentheses there.
So remember what he's telling you. If you are being lazy, which is fine with us because all mathematicians are lazy, and you're typing this into the calculator instead of doing the arithmetic in your head, if you don't put the parentheses, you're going to get the wrong number 99.99999% of the time.
Yep. So if I do that again with, and you can do it again with 2 and negative 2. When I do that, I believe I get positive 2 out, right? Because 2 squared is 4, minus 2 is 2. And the same thing when I take negative 2 squared, I'll get positive 4, I'll get 2 out. So I have 2, 2, and then negative 2, 2.
Quick reminder, and I'm sure you all remember this, but remember the first number in the ordered pair is the x value, and that's where you're going left and right on the graph. And the second number is in the ordered pair is the y value. That's where you're going up and down on the graph.
I'm beginning to see a pattern here, although I can't draw it very well. And I don't have the desire to do a ton of more of these. And we probably won't ever really make you do more than these, but that's what it's doing. It's actually plotting a ton of points. Now, maybe some of y'all are interested in computer science, but all of this, the guys who made your friendly neighborhood calculator, mine's somewhere in my bag, they made a program to do just that. All they did was have it plug numbers in and make points on a grid. And they made this program in the early 80s. 2 guys at Ohio State named Bert Waits and Frank DeManna, and they made a real simple computer program that would just plug in numbers into an equation and put dots. And they sold it to Texas Instruments, and one of them died. One of them died a few years ago, and he has a mansion in Florida, had a mansion in Florida, and a yacht. So like millions. Okay. So anyway, I could do this until the cows come home and get a better picture, but I know what this graph is. You probably knew what this graph was. So I don't really want to do this by hand.
Mr. Bobby, how can we use this graph to determine if something's going to be a function or not?
Oh, we'll come back to that.
Oh, fine.
All right. I just wanted to show off my motorcycle.
Of course you do. Hi, welcome to the motorcycle.
How beautiful that beautiful motorcycle. Well,
doesn't it make you want to sing black and yellow, black and yellow? No? Okay.
Oh, it's not. Okay, stop. So y'all should have a TI Inspire, and I don't know if you use them in your other classes very much, but we're going to use the Inspires in here. So am I okay to do it like this, or should I make the screen bigger?
I think it's fine.
Just a quick tutorial. It's a document-based calculator. So the home screen, if you turn it on, when you turn it on, or if you hit on, it'll take you to the home screen back there. So we want to start with a new document. Always start with a new document, at least when we're doing a new activity, and we're making a graph. So I'm going to arrow down and add a graph. And this is kind of cool. It's actually, I think it's a little easier than an 84 in some sense. It tells me the f1 of x, I've got in 3 place. So I'm just going to put x squared, hitting the buttons, and it was -2, right? And when I hit enter, presto, it did it for me. And all the calculator does is it plots like 300 points or more. Or actually, I think it's like, in this.
Will you split the screen and show us the table that we just made?
I could do that. There you
so
go.
you just hit Control T so that we can also see the table, which reflects what we just did in our heads, right? We plugged in -2, we got 2. We plugged in -1, we got -1, and so on and so forth.
So it does a table for, it's making a table. Now it's actually doing all the ones. I wasn't mean in making you do like 0.3 and 0.609 and point whatever. It's doing all those points all along the way and connecting all those dots to make this lovely graph. Okay.
We could change this table so that it counted by 0.1 or 0.2 or something like that. So you might see like 1, 1.1, 1.2, 1.3, and it's plugging all those in. We're not going to, but we could.
Oh, motorcycle. I'm petting my.
Oh my God, go away, go away. They're sick of listening to us. They want this video to end.
I want this video to end. All right, let me get back and finish up the last line. So Miss Young couldn't keep herself quiet. How do we tell if it's a function vertic? We need the vertical line test. And the reason basically that this works is if I draw a vertical line through it, and maybe not, that's the last thing. Why don't I pick up the pen? If I draw a vertical line through it, which is not even remotely vertical.
It's important that it's vertical, guys.
Why is it important that this is vertical? What I'm saying here, this represents some X number. Okay? And I have two Y values. There's Y1 and there's Y2. So you probably have seen this too. It's a really easy test. But if you look at a graph, if a vertical line is able to intersect it more than once, that violates the exclusivity part of the definition of a function.
Yeah, remember that your X values should map to only one Y. In this case, you've got an X number mapping to a Y1 and a Y2. Boom, done, can't work.
And that means I don't have predictability. It doesn't mean there's not a relation. There may be some mathematical relationship, but it's not a predictable relationship. And that's what we want with a function, okay? So what about the one in the middle? Is that one cool or is that one not so cool, Ms. Young? What do you think?
Well, I'm looking at it, and I'm looking at it from left to right and seeing if I've got 2 points stacked right on top of each other. And it looks like at approximately positive 3 X value, I've got 2 points that are stacked right on top of each other, meaning that you've got an X mapping to 2 Ys, and it's wah, wah, wah.
Nope. Okay. And then the last one, I think we're good, right? I can do that with a bunch of different, let me change the colors because you're probably worried about me with the pink and all. So, but if I tried and tried and tried and tried and tried, I'm never able to violate it. What did you just do? That doesn't matter. All right, so that one is, yay, it's all good. Okay, so that one's good. All right, so that's pretty much section 1.2. We skipped section 1.1 because it was a lot of the T-chart and graphing, and we're going to get through chapter 1 as kind of like a prerequisite stuff. So that, we're going to test it. We're going to have quizzes over it, but this shouldn't be completely earth-shattering new. Now, if there's stuff there that you don't understand, that's what we're going to be available for tutoring. When we get into chapters 2, 3, 4, and so on, there'll be stuff that might be a little bit more new to you. Okay.
Or maybe not.
Maybe not. I don't know. We'll see.
Depend on where you came from.
Yeah. And if you're taking calculus or not concurrently, or statistics or whatever. But there are some practice problems. What are you doing?
I was pointing to all the practice problems.
Oh, actually,
are they over there?
Where you are now, point to your other side.
Oh, wait. My people are in a different place than your people.
Yeah, I move you around. I'm moving you around so you're out of the way. They're right there.
You know, some of my stuff that I do when I thought I was pointing at you isn't going to make sense because on my screen, we're at the top.
Oh, I moved you around to get you out of the way from time to time.
Oh, okay.
Folks,
so if I go like this, am I pointing at the practice problems?
No, you're pointing at the side of the screen. You're pointing over to my.
What about this way?
Okay, now you're pointing at the practice problems.
Okay.
Folks, we hope you enjoy this course. We are going to try to have a little bit of fun with it too. But seriously, get some problems in there, practice them, and we will continue to just go on.
The old adage of practice makes perfect is false, but it does make you better. So.
Share. Anything else we need to say other than, do y'all want to see my motorcycle one more time? No?
They don't.
Okay.
They don't. Bye, guys. We'll see you for the next one.
All right. Bye-bye.